This video is on the Lewis dot structures of atoms. I have the periodic table up here, and we're really just going to be working with the representative elements. Right here, do it in red, and over here. The first thing we want to do is connect it to the electron configuration. Let's look at some of these atoms. Hydrogen is 1s1. Helium, if you remember from 101, is 1s2. Lithium is 1s2, 2s1. If you haven't figured it out, stop the video and get a periodic table out. Beryllium is 1s2, 2s2. Boron up here, carbon, nitrogen. So boron is 1s2, 2s2, 2p1. Carbon 1s2, 2s2, 2p. So I've rearranged and put them in a different position so this works a little better. And I need you to stop the video and write out the electron configurations up through neon right here. Okay, so you need to do nitrogen, oxygen, fluorine, and neon. Okay, so here they are. And what 1s, nitrogen's 1s2, 2s2, 2p3, fluorine 1s2, 2s2, 2p5, etc. Okay, and we don't want to write all this out all the time. If I drew the orbital energy diagrams for hydrogen, it'd be 1s. We'd put a 1s under there. For helium, it'd be 1s with 2 electrons on it, 1s2. For lithium, it'd be 1s and a 2s. And, you know, boron, 1s with 2 electrons in it, a little 1s under there, a 2s with 2 electrons in there, and a 2p with 1 electron. These, of course, are the valence electrons. So when we do Lewis dot structures, we don't want to write all this out. So we write it out for the valence. So what we do is I'll take a nucleus for hydrogen, I'll write H, and I'll put the number of electrons in there. And I only put valence electrons. So here it is. And the dot represents a valence electron. So helium would look like this. And it has 2 valence electrons. So I can put a dot here and here. Oops, I drew them in red. Here they are in black. Or I could also write it this way. And you got to be careful, but I can write it like that. So a dash represents 2 electrons. And a dot represents 1 electron. Important. So then when I go to lithium, it has 1 valence electron. So I'm going to put my lithium right here, and I'm going to put 1 valence electron. Don't mess up the I and the electron. Beryllium, see if you can do it. Try beryllium and boron. So beryllium is going to have 2s2, so I could either write it like this, or I could do this. Either one would be the same. Now if we look at boron, we notice 2s2, 2p1. So boron will have 2 in the s and 1 in the p orbital. So we're just going to put them around here like that. I could do it like this and 1 here. Now carbon, so notice I'm filling up the s, so I put both electrons in the s orbitals here for the s. The p orbitals are going to be represented in general like this with the atom in the middle. Here's my 2 s electrons, and then I'm going to fill the 3 p orbitals up. Px, py, and pz are going to be filled up one at a time, putting 2 electrons in each. So when I do carbon, here we go, carbon, I have 2s2, 2p2. So here's my 2s electrons, and here's a 2p. It goes into px and the py here. So they're separated. Now, the relationship here, if I can do it, is Here's my valence electrons. 2s, 1, 2, and 2p. Remember, they fill singly. 1, 2. So that's why I have it, the electron dots separated here. Nitrogen would be looking like this. You should be able to do these. Try it. I'll do nitrogen. 1s2, I can draw it like this. 2p with 3. 1, 2, 3. I'm filling singly. Now I'll start to fill doubly next. Or possibly this one. So do the rest of them. Do fluorine, oxygen, fluorine, and neon. Pause the video, then do them. So here we come back. I'll do oxygen for you. You should have had this. Oxygen, 1s, 2s2, 2p4. So I fill them 1, 2, 3, and then double up. So I could also did this. Fluorine will have 1, 2, 3, 4, 5, 6, 7, and neon will have 8. 2, 4, 6, 8. This works out. That's all the electrons we can put around the atom. That's not quite true, but for this class, it's absolutely true. Okay, so this is the relationship. You should be able to do something like sulfur. Go ahead and try sulfur. Pause the video and do it. All right, so if we look at the Lewis electron dot structure for sulfur, the valence is 3s2, 3p4, and so I would come down here, sulfur, 3s2, 3p4, and it would look like, here's my 2 s electrons, then 1, 2, 3, 4, or I could have drew it like that. Whatever I do, I cannot do this. That is a big no-no. That's it for this outcome.